are continuing the discussion on the same topic of intents. Now, please welcome to the stage, Train Protocol's Aram Kocharyan. Welcome to the stage.
Hey everyone, hello. Today I'm going to talk about Train Protocol, but first of all, let me make a bold claim to make you interested in this speech. So all existing interop protocols right now are heavily centralized or heavily depend on centralized operators. And the discussion I want to have today is two questions. How did we end up like this? How did we end up with a situation that almost all interop protocols are centralized and everyone is fine with that? And how we move forward. For that, I plan to talk about I plan to tell you the story, our story, because we are the one that built a centralized bridge before. So it's LayerSwap. I want to tell you how, bit by bit, step by step, we end up with trusted centralized bridge and how we can overcome it. Everything started in 2021 when there is L2 boom, Arbitrum, Loopring, ZK Singlite, and everything else. And we were just three guys sitting together, exploring crypto, trying to find some problems to solve. And exactly this time, my co-founder asked me, hey, if I have my assets in Coinbase account, how I move them to Arbitrum, let's say, because at that time, Coinbase was not supporting Arbitrum. And it sounds really interesting problem, and it sounded a problem that we could solve. So what we did is, we created the first version of LayerSwap, and the main idea of the LayerSwap was to transfer your funds from Coinbase or from any other centralized exchange to Layer 2. And the way we did it is we had a Coinbase account. So as a user, you will transfer from your Coinbase account to our Coinbase account. Then we have funds in Arbitrum. We transfer from our Arbitrum account to your account. So very simple. And it worked really well. At this time, everyone was talking about LayerSwap. It was really insane. We had growth unimaginable. Then what happened is we had the new networks coming, ZK Sync, Arbitrum, Optimist, and we just kept adding all these networks. So we had this exchange-to network, basically going from Coinbase to ZK Sync, and we also have a network to exchange, so we're doing the same opposite. So far, so good, until one of my co-founders, the same guy, asked me another question. Wait a minute, so we have accounts in all Layer 2s, we have liquidity in all Layer 2s, why we are only doing centralized exchange to Layer 2? Maybe we should do just Layer 2 to Layer 2, because we already have these accounts. Users can just transfer to our address, and then we can do the counterparty transaction in destination chain. You see that new flag? So we added this cross-chain tab. It's like new shiny bridge. And obviously, it was completely trusted. So we were just a trusted, centralized operator. We were receiving the funds in source network, in EOA, and we were executing funds in destination network. And everything was working fine. Users were using it. No one was seeing any problem with that. No one was complaining. Even the really good protocols that had really good decentralization and really minimized trust assumptions were not working, but we were working. We were growing. All of this happened until 2024, when we started asking us questions, why are we even doing this? What is the reason of building so important infrastructure component in a centralized and in an unresponsible way? And it was like kind of a crisis inside company, because I was complaining about this doesn't make sense, we don't need this product, it's not important. In 2 or 3 years, it's not going to be relevant at all. And it's so important infrastructure piece, we have to do something with it. And after these discussions, after a lot of fighting with my co-founders, a lot of researching, a lot of idea generation, a lot of brainstorming, we finally understood and realized one important thing. We were thinking about Interop as an end-user product. We were thinking about this, hey, okay, so users want to go from one chain to another chain, so we make it fast and cheap. And that was also because, I don't know you remember or not, but at that time there was this big narrative in crypto. Everyone was complaining, hey, you all are building an infrastructure, whatever you are building is not important, it's not giving the crypto adoption, and we were under that narrative as well. So we realized that in order to build actual value in Interop, you have to realize that Interop is not an end-user product. Interop, it's infrastructure. It's really important infrastructure. And by doing this, when we changed our perspective about thinking Interop, we started designing, okay, so how that infrastructure should look like, how we want this infrastructure to actually look like. And we just pinned it down to two main attributes. The first one is trustlessness. So the protocol itself, when users are moving funds from A to B, users should not trust anyone in this path. They should not trust any custodian. They should not send their funds to anyone, any multi-sig, any contract. Users should be able to do it without giving away their assets, even if they are a reputable and working company. And we know like not everything goes well with blockchains. Blockchains can get stuck, they can get hard forked or whatever. So users should be able to refund their funds if something went wrong. If the solver is not working, if RPCs are not working, or anything is not working, users should be independently able to refund their funds back if the swap is not happening. So that's about trustlessness. But the second most important thing is permissionlessness. During 3 years of operating LayerSwap, every week we are talking with a new network. Every week. New networks are calling us, hey, guys, can you integrate new network into LayerSwap? And this is a huge pain point for networks. In order to have an interop solution, so they can onboard their users, they have to get, I don't know, they have to get a lucky VC or these big boy guys, or they have to pay money for a network integration. So permissionlessness is really important thing for a protocol. So if there are new networks, they will be able to join the protocol from first day, and there should be no company, no gatekeeper stopping them doing that. As we defined what is the problem and what we want, let's step back and see what is the actual problem with Interop, why it's so hard. And it's actually really simple to articulate. The problem is the state problem. So Optimism don't know what is Starknet. They don't know it. In Optimism universe, there is no Starknet. For Optimism universe, there is no Solana. So all these networks keep their state, and they don't have any idea about other chains. And how you would solve this is if you have a third party or any party that can provide a trustless cross-chain messaging between one chain to another chain. If we can have a trustless cross-chain messaging, that problem will be solved, right? Because you will be able to pass data, cold data, or whatever from one chain to another. If you had this, no problem. When you have this, the problem is that we don't have it. And we couldn't find a solution ourselves. When we were trying to solve this problem, we couldn't find any way to implement a generalized cross-chain messaging in a trustless manner. Good luck, other teams. But what we did is, we decided to narrow scope down to asset bridging and swaps. Only asset bridging and swaps. when we narrow down the problem, we already see in this market how like intent solver systems, not specifically intent solver, but the systems where user is sending funds and someone is giving funds in the destination network. Let's call it intent solver to not confuse with anything else. So how that works? User is committing funds in the source network, and solver is ready to give funds in destination network. In this design, we basically have two parties, user and solver. And we already had a mechanism that is like well invented maybe 10 years ago, atomic swaps. So when you have atomic swaps, you don't need any trusted third party. So two parties can exchange assets using atomic swaps. And to give you a quick intro to atomic swaps are all around HTLC contracts, hash time lock contracts. The way atomic swaps work is user is generating secret, calculating hash of this secret, and locking funds in source chain with two conditions. One condition is if the secret is revealed, funds are going to solver. Second condition is if time lock passed, let's say 15 minutes or 20 minutes passed, user can claim funds back. Once user does this transaction, solver, to whomever user created the contract, sees this transaction in source chain and creates counterparty contract in destination chain with similar conditions, with same hash lock, the hash lock that user owns the secret, with same hash lock, but when the secret is revealed, funds are going to user. Solver does that. When user detects this, when user sees in destination network, hey, wait a minute, there isn't a contract, I can reveal my secret and claim funds. User goes to destination network, does the transaction to reveal the secret and claims the fund. Once it's done, secret is right now public, so solver can take the secret, go to source chain, and claim their funds back. So far, so good. But we can already see few problems with the design. The first problem is secret dependency. The user in this design is responsible for handling secret. User is responsible to managing the secret. Either it's in your local storage or in your wallet, but what if the cache is cleared or whatever, so it's a big dependency on a user. So if user lose this, it's going to be a problem. But funds are safe. So even if you use the secret, you are just going to wait for time lock and get the funds back. The second problem is, right from beginning, user is committing one-to-one with solver, right? Because the user is locking the funds exactly for the solver. So that's one-to-one with the solver right from the beginning. And the third problem is user has to do transaction in destination chain. Imagine like user wants to get some ETH in Optimism, and when they go from Arbitrum to Optimism, you ask them to do a transaction in Optimism. So it's not going to work. And relayers here are not going to work as well. So I mean, maybe you are thinking, oh, wait a minute, so you can give this secret to anyone else so they can execute the transaction for you. No, it's not going to work because secret, user can't reveal the secret before the swap. Because if you reveal the secret to some relayer or someone, what if that someone was the solver itself? If you reveal this secret accidentally to the solver, solver will go to source chain and claim your funds, and swap will not happen. So you can't lose control of the secret. Now we know the problems, so we narrowed down to solve this problem. And introducing pre-HTLCs. It's basically the same atomic swap concept, but with a few nuances. So the first step here, user is just committing funds. User is not generating secret. User is not taking the secret. They are just committing funds, telling that, hey, I want to bridge somewhere, like telling the destination network, telling the destination amount, and that's it. And user is committing the funds for all solvers. There is no single solver at this stage. Once all solvers see this transaction in source chain, and the solver who is willing to do the swap generates a secret and calculates the hash of the secret and creates the HTLC contract in destination chain. So now you have user committed in source network and you have a HTLC solver committed in destination network. So now user's job is to observe the destination network, see the hash log, they just see it in a contract, so see the hash log, copy that hash log, and apply it to your original commitment. Now you are locked with solver one-to-one. You don't manage the secret. Secret is managed by the solver. And once you do this commitment, once you finalize your commitment, now you have two contracts, same hash log, all the same with atomic swap. So solver, what does the solver do in this situation? They take the secret, they go to source network, release their assets, and they go to destination network, release users' assets. Okay, there is a problem. Because what if solver doesn't release the user's assets, right? Solver is incentivized to release their assets, but is not incentivized to release the user's assets. In that case, we introduced a reward mechanism for solvers. So whenever solvers lock in destination, they lock 10% more of their original amount. And this 10% more is refunded when the solver is actually releasing user's fund, or is reserved for anyone, whoever is willing to grab that 10%, they can go and grab that 10%. By doing this, we incentivize solvers to release the user's fund. And introducing you the train protocols. I already told about contracts, that contracts are the first most important thing, but if we take the contract, the protocol itself has very wide usage because, let's say, let me go back. So in this step, when user is reading the destination network to grab the hash log, how they are reading it? They are reading it with RPC calls, right? So we don't trust RPCs. So how can we do it? We can have light clients running inside the browser to not trust the RPC, but read the state of the chain through light client, so you can actually get the hash log and apply to your source network. So train protocol is combination of all of these. So we have contracts, we have solver, we have wallet SDK, which have a native integration with Helios like light client. So everything is in one package, and we call it train protocol. Demo time. So I have a recording of the demo. Someone told me, don't do the recording, do the actual demo. So I will try the actual demo. If this works, of course. Let me see. New tab. How to exit this mode? OK. So I go to app.train.tech. Let's try a demo from Starknet mainnet to base. Let's connect my wallets. I will connect my Ready wallet. And I will connect my MetaMask. So far, so good. OK. So let's see. As I described the flow here, the first step is to commit to all solvers. So I commit my funds to all solvers, whoever is ready, whoever is willing to do this swap, they will just come right in. So I'm committing my transaction. This is transaction in Starknet mainnet. Once my transaction is confirmed, and I hope it will be soon enough. OK, it was very fast. But once transaction is confirmed, one solver automatically detected my transaction and now reserved assets for me in destination network. And it's what is happening in this loading. First, we verified it by RPC. We get with RPC the hash log, and everything was fine, while Helios was verifying it with light client. Once it's verified, I don't trust here anyone, like no one. So I can just go here, finalize my swap. This is the step that I apply my hash log to my original swap. I finalize my transaction, basically applying my hash log to original contract, and swaps is going to be completed in few seconds. So if you think about this, it just takes around it's not fast enough, like, I don't know, like LayerSwap, like our centralized service. It takes like 3 seconds to do this swap. It takes like 10 seconds. But the important thing is that I didn't trust anyone here, like literally no one. No one had a chance to do anything bad with my money. So this is a transaction. It's confirmed. I get my funds. OK. So to recap what we just saw, is we saw train protocol, which has no intermediaries, only user and solver doing an exchange with atomic swaps. Anyone in this design can join to train protocol. What is necessary is only pre-HTLC contract deploy on your network and the running solver. There are no gatekeepers, no companies controlling this. Everyone can just deploy the contract, run the solver, everyone will be able to join, and everyone will be able to swap. Pre-HTLC contracts are around 200 or 300 lines of code in Solidity, are very simple contracts. They are non-upgradable. You just deploy them, you just forget about them. And finally, these contracts can be implemented for any VM. We already did implementation for a bunch of VMs, like Solana, Starknet, Fuel, and probably Bitcoin. I'm not sure yet. And there is one more thing. Everyone was talking about private bridging. Train protocol design allows us to have a private bridging with Aztec. So I can do the demo of this as well. If I go to testnet.train, but I'm not going to do it. I'm just showing that you can try at home. So if you go testnet.train.tech, you will be able to do the demo. I am showing the video because the way Aztec works is they are proving each transaction. So like the whole swaps takes like 30 minutes. So I don't want you to wait here, but you can go to testnet.train.tech, and you can go, let's say, from Ethereum to, oh, we don't have Ethereum to Aztec. So we have probably from, I don't know. Anyway, so you can go and trade. So I will show you the demo. OK, everything is happening as before, but you will see here. So we are going from Ethereum Sepolia to Aztec testnet. We are connecting the Aztec wallet, connecting MetaMask. OK, so everything is almost the same. So first step is, again, confirming the details. You basically commit in Ethereum network, telling, hey, is there anyone who is going to, who wants to reserve any assets for Aztec? So now, solvers in Aztec network are trying to fulfill this. So this part is speeding up. So it's not like this. So I will just speed it up faster so you can see. OK. So once one solver lock the funds, I do the finalize, and I just say, OK, finalize. But you can see here that I have one more step, manual private claim. Let me speed it up as well. OK. So once the exchange happened, but it's not really finalized yet, because you want to keep it private. You don't want the solver to send you the funds. So Aztec solver is preserving the funds for you for the key that you only own. So this claim transaction is right now going and privately executing, providing the key and claiming funds privately. So not a solver, no one in between knew that you actually received these funds in Aztec network. That's it. Thank you very much.